So, welcome to Chapter 9. Chapter 9 is all about sequences and series. So, let's get started with 9.1, where we talk about what a sequence and what a series is. Sequences. In mathematics, a sequence is a list of numbers. For example, 1, 2, 3, 4, 5, dot, dot, dot. That is a sequence. 1, -3, 9, -27, 81, dot, dot, dot. That is also a sequence. 4, comma, -17, comma, 3/4, comma, 10. This is also a sequence. Any list of numbers is a sequence in mathematics. Now, more often than not, there is some sort of pattern between each of the terms in your list of numbers, right? But there does not necessarily have to be a pattern. You can think of a sequence as a function whose domain is the set of positive integers. Rather than using function notation, however, the sequences are usually written using subscript notation. So function notation, you guys are all familiar with. We use f of x to represent our function values. Instead of using function notation, we use subscript notation with the subscript a subscript n representing each of the terms of our sequence. Analyzing the second sequence from above, this one right here in the middle, we see that a1, a subscript 1, or a sub 1 is equal to 1. In other words, the first term in the sequence is 1. A subscript 2 would be -3. That's the second term in the sequence. A subscript 3, that would be 9, the third term in the sequence. A sub 4 would be -27, the fourth term in the sequence. A sub 5 would be 81, the fifth term in the sequence. And the nth term of the sequence would be given by the expression a subscript n is equal to -3 raised to the n minus 1. This equation right here gives the nth term of the sequence. Now, later on in sections 2 and section 3, we'll talk about finding nth terms of particular types of sequences. So don't expect you to know how to do that just yet, but keep that in mind as we move forward. Now, there are two different types of sequences that we need to be familiar with, and those are going to be infinite sequences and finite sequences. An infinite sequence is a function whose domain is the set of positive integers. So your inputs are all positive integers. The function values are a subscript 1, a subscript 2, a subscript 3, a subscript 4, dot, 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 a subscript n, dot, 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 meaning that there are an infinite number of terms in the sequence. All right, those would be the terms. If the domain of a function consists of the first n positive integers only, the sequence is a finite sequence. There are a finite number of terms in the sequence. So notice up here, let's look at these first few examples again. This first one is an infinite sequence. How do we know this is an infinite sequence? It has a dot, dot, dot next to it, meaning that the list is going to continue onward. Same with our second sequence that we see here. We have a dot, dot, dot at the end. That means it's an infinite sequence. The list continues. Whereas our last example here, 4, -17, 3/4, 10, we see our list terminates at 10, meaning that this is a finite sequence consisting of only 4 terms in this particular case. All right, so a sequence is a list of numbers. We have infinite sequences, we have finite sequences, and we use subscript notation to represent the terms of each sequence. Let's go through some examples here where we find the nth term of the sequence. Find the first 4 terms of the sequence, assume that n begins with 1. Now this is a lot like evaluating functions. The first term, assuming that n begins with 1, would be a subscript 1. Notice, we replaced n with a 1, therefore we are going to plug in 1 for every other n that we see in the equation. A1 is therefore equal to 1 minus 1 quantity squared divided by 2. Well, simplifying that down, that gives us 0. The next term in the sequence would be a subscript 2. Notice we have a 2 as the subscript. We are replacing this n in our equation with a 2, which means we plug in 2 for every single n that we see. 2 minus 1 quantity squared over 2, we simplify that down into 1/2. The third term of the sequence would be a sub 3. This means I just plug in 3 for n. This would be 3 minus 1 squared over 2, which gives us 2. The fourth term, a sub 4, would be 4 minus 1 quantity squared over 2, which gives us 9 over 2. So finding the nth term of a sequence is just like evaluating a function. Whichever term we are trying to find, we're going to plug that number in for n. So that means to find the 25th term of the sequence, a sub 25, we are going to want to plug in 25 for n. This would be 25 minus 1 squared divided by 2. Plugging that into our calculators, we end up with 288. Now, use a graphing utility to graph the first 10 terms of the sequence. So yes, we can graph sequences in our calculator. And to do that, we want to begin by hitting the mode button. And once you hit mode, scroll down to the 5th line here and go all the way to the right, and you want to select sequence, all right? We want our calculator to be in sequence mode. It was probably in function mode from your previous setting. Select sequence mode by hitting enter. Then hit your y equals button, just like you were going to plug in a function. Well, now that we go to y equals, you'll notice that it looks a little bit different here. All right, yes, instead of having y equals, we have u of n. This is just what this is going to look like when we're in sequence mode. This is talking about a sequence u as a function of n, your inputs. And you are going to plug in. Well, you don't actually have to type in n. You just use the variable button x, and an n will automatically pop up. Parentheses, n minus 1 squared divided by 2. Again, you don't have to use the letter. Just hit your variable button x, which you are used to using when you plug in functions into your calculator. Now, hit window. We want n to begin with 1, right? We're assuming that n begins with 1. And because we are looking to graph the first 10 terms, we want n max to equal 10. The rest of your settings should be the same here. Plot start at 1, plot step at 1, x minimum. I like to make my x minimum -1. We're starting by plugging in +1, so seeing -1 on the left-hand side just gives me a little bit more space. X max, I've got 11 plugged in for x max. The greatest value of x that we will actually plug into our sequence is going to be 10, so having 11 gives us a little more room on the right-hand side. Then, for y min, I have -2, and y max, I have 50. Now, these numbers I've obtained because I kind of already know what the graph is going to look like, but you might have to do some playing around with your y min and y max values to get a graph that shows all of the terms of the sequence. But if you have it set up just like this, and you hit graph, you end up with your sequence. And notice that instead of a smooth curve with a line connecting all the dots, you just have all of these dots in between. And the reason is your inputs are only the integers, right? We plugged in 1, we plugged in 2, we plugged in 3, 4, 5, 6, 7, 8, 9, and 10. Those would be the first 10 terms of the sequence. Now hit trace on your calculator. And if you hit trace, it will actually tell you the terms of the sequence. So when n is equal to 1, y, the output is equal to 0. That's what we found. We found a1 was equal to 0. If we use the right arrow button, we can scroll to the next term in the sequence. When n is 2, y is 0.05. We found a sub 2 is equal to 1/2. Scroll to the right. A subscript 3, that was equal to 2. A subscript 4 was 4.5, so on and so forth. And we can get our list of the first 10 terms straight from our graph. Okay, let's do a couple more examples here. Find the first four terms of the sequence. Assume that n begins with 1. Here we have our sequence a sub n is equal to negative 1 raised to the n plus 1 divided by 2n plus 1. To find the first term, all we do is we plug in 1 wherever we see an n. This is negative 1 raised to the 1 plus 1 over 2 times 1 plus 1. Plugging that into our calculator and simplifying, we end up with 1/3. Now, if you are plugging this into your calculator all at once, just be careful. All right, make sure you have this exponent all grouped together, and you will need parentheses around your entire denominator. To find the second term, that means we plug in 2 for n. This would be negative 1 raised to the 2 plus 1 over 2 times 2 plus 1. This gives us negative 1/5. A sub 3, the third term of the sequence, we plug in 3 for n. Negative 1 times 3 plus 1 divided by 2 times 3 plus 1. This gives us 1/7. A sub 4 would be the fourth term of the sequence. We plug that in. We plug in 4 for n. We get negative 1 raised to the 4 plus 1 divided by 2 times 4 plus 1, leaving us with negative 1/9. Now, use a graphing utility to graph the first 10 terms of the sequence. Again, you're going to hit y equals. Clear out the last sequence if you have one in there, and replace it with negative 1 raised to the n plus 1 divided by parentheses. Notice I have the entire denominator in parentheses, 2n plus 1. You can change your window here. Again, we still want our n minimum to be 1 and our n maximum to be 10. That will give us the first 10 terms. X min at negative 1 still, and X max at 11 still. Notice in this case, I have changed my Y max and Y minimum values, and I did so noticing that the values of each of these terms are pretty small. So I made my Y min negative 1/2 and my Y max positive 1/2. Then hit graph, and hitting graph will spit out the graph of our sequence. And notice that the terms here actually alternate between being positive and negative. And we are able to clearly see all 10 terms of the sequence, the first 10 terms of the sequence. One more. Find the first 4 terms of the sequence. Assume that n begins with 1. Here we have a sub n is equal to 6e. This is an interesting one, right? So what would be the first term? Well, again, the first term would be a sub 1, and that means we need to plug in 1 wherever we see an n. Well, there actually isn't an n in this sequence, which means I don't have anywhere to plug in a 1, meaning I'm going to get out 6e. That is going to be the first term in the sequence. A sub 2 would be the second term in the sequence. Well, I don't have anywhere to plug in a 2. That means the second term is also going to be 6e. And the third term is going to be 6e. And the fourth term is going to be 6e as well. All right? Yes, because 6e, that is a constant, all right? That means the outputs, the terms of each of the numbers in the sequence is going to be 6e. Use a graphing utility to graph the first 10 terms of the sequence. So again, we hit y equals. We plug 6e into our sequence here. I've changed my window around a little bit. I've changed my y minimum to negative 2 and my y max to 20. All right. And if I hit graph now, notice we end up with a horizontal plot of points. Okay. Each of my outputs for this sequence is going to be 6 times